Now we know that we can travel around a circle more than once. We can go backwards around a circle into negative angles. We can go around more than once. So basically these graphs, the sine and cosine and tangent graphs, don't just go from 0 to 360. They repeat endlessly. And so we're just going to draw two sections of it. We're going to say what happens if we go from negative 360 to positive 360. What would it look like? So we're going to start by just looking at key points. We're not going to plot as many points as we did when we just made one section of the graph. Here's what I would like you to do when you plot a graph of sine. I want you to think of what sine of 0 is, sine of 90, sine of 180, and actually, you know what? I'm going to write these over here because I want to do something else on that space. So sine of 0 is 0. Okay, there's 1 point. Sine of 90 is equal to 1. Sine of 180 back to 0. Sine of 270 negative 1. And then sine of 360 is the same as sine of 0, so we're back up to 0 again. Now when you draw this, don't do this. This is not a pointy graph. It's not pointy like that. Don't draw it like that. It curves. Okay? So above the x-axis, it curves down like this. And actually, it goes through 1/2 at 30 and at 150. Sine of 30 and sine of 150, because this is 30, 60, 90. That's 30 right here. And this is 150. It's going to be at 1/2. So that kind of helps you if you need to know how to make it curve. So right here and here, it's also going to be 1/2 at 210 and at 300. Okay, so there's the curve. Now what happens as we go backwards? So let's think about 90 to negative 90. Negative 90 is the same as which one of these angles? Well, if we draw 0, 90, 180, and 270, now think about going backwards. Negative 90 is the same as 270, so it's going to be at negative 1 again. So we keep going down here. And then negative 180 is the same as positive 180, so we're back to 0. Negative 270 is the same as 90, which is positive 1. And then, of course, negative 360 is the same as positive 360. So we're going to go down, curving nicely, and then back up like this. Okay, so there are two cycles of the graph. Now, if we go down to the bottom, actually, we won't do that yet. Let's go ahead and do cosine. So now let's think about cosine. Cosine of 0 now is equal to 1 because we're starting up high. So remember, sine is a snake, starts at 0 and slithers around the x-axis. Cosine is a cup that starts up, so it starts up high at 1. Then cosine of 90 is 0. Cosine of 180 is negative 1. Cosine of 270, back up to 0. Cosine of 360 is positive 1 again. So we're back up to the top. Now once again, this is not a V. Don't draw it like that. Bad, bad, bad. Don't do that. Curve it down. This is 60 right here. That's where cosine is 1/2. Cosine is also 1/2 at 300. So curve it down over here like that. And then these two places are negative 1/2. Curve it like a kind of a bowl shape, you know, in the middle here. Curve it up. That looks lovely. Now, let's look at think about negative 90 is the same as positive 270. Okay, so it's going to be at 0. Negative 180 is the same as positive 180. So we're going to be at negative 1 here. Negative 270 is the same as positive 90. We'll be right here again. And then back up to 1 at negative 360. So notice that cosine looks the same on both sides of the y-axis, whereas sine does not. Okay, sine cuts down through, kind of looks the opposite, you know, kind of symmetric through the origin here. This is a symmetric across the y-axis. Okay, now let's stop for a minute and look at the bottom here. We want to define the domain and the range of each function. Now, some of you may remember that. Some of you may not remember domain and range. I'm going to give you a little help remembering the domain and range. So just kind of over here, I want you to write D-I-X-I and R-O-Y-D. And I'm going to introduce you to my hillbilly cousin from Appalachia. Actually, we need to spread this out just a little bit. Sorry about that. So here she is. Hey y'all, my name's Dixie. I come from Kentucky. Actually, I used to come from West Virginia. That's really my home, West Virginia. But I live in Kentucky now. So I want to tell you about domain and range because my name and my brother's name really they act like an acronym for this great concept. I teach math too back in West Virginia and in Kentucky. So domain is my first letter of my name is D, and that stands for domain. D-O-M-A-N-E, domain. And domain is the X variables, the set of all the X variables. So you think Dixie has a D and an X, domain is X. Now what about the two I's? Why do I spell it D-I-X-I? Make these look like little I's instead of. So one of the other names for an X variable is we call it the input variable. It's the input that goes into the function, and then the Y is what we get out. We put in the X. So like we put in the angle for cosine and sine, and we get out a trig value. So this is the input. We also call it the independent variable. Independent variable. We call it the independent variable because we get to pick what we put in for the X variable, and then what we get on for Y depends on X. Kind of free choice, independent variable. Now I have a brother. My brother's name is Roy D. I have some other brothers too, but he's my favorite brother. Roy D. We call him Roy D because my daddy's name is Roy too. So we use Roy D because his middle name is Dwayne, Roy Dwayne. And so that helps tell us apart from Roy, my daddy. So Roy D. also has a cool acronym with his name. Very helpful. So we say range for R, and then it goes with Y. So it has an R and a Y, so range goes with Y. Y variable. Variable. There we go. That's kind of messy. I probably ought to erase that and spell variable right. I think I did the same thing in my other one. Variable. There we go. Now, if domain is an input, I bet you can figure out, you guys are so smart, Y is an output. You put something in, you get something out. And it's a dependent variable because what we put in for X causes Y. So Y depends on what we put in for X. So it's a dependent variable. So if you can remember these acronyms, Dixie and Roy D, it helps you remember domain and range. Well, that kind of slows down a little bit, so we'll go on for now. I'll give you back to Mrs. Taylor now. Thanks, Dixie. That was really helpful. Hopefully, Dixie's little acronym will help you remember domain and range. So if we look back at cosine and sine, we see that the domain on the x-axis is the angles. And since we can go around and around in the circle backwards and forwards as many times as we want, we have an unlimited amount of values that we could put in for x. Any possible angle, negative or positive, we can think of. So we say that the domain is all real numbers. Now, another way we can write that is negative infinity to positive infinity. In other words, any number I can think of, I can put in for the domain. And these happen to be our angles in this case. So our angles can go from positive to negative infinity. Now the range, we have a limit here. The highest we can go is 1, and the lowest we can go is -1. So we say -1 is less than y is less than 1. Now, I'm going to teach you how to do something called interval notation. In interval notation, we would write it this way. And I'll give you a little more formal training on that in a while, but we just write it with brackets around it. We say -1 to 1. And just for your information, I'll just kind of put this over here in a little thinking about, if I had -1 is less than y is less than 1 without the equal, then I would write it like this with curved brackets. So this is interval notation. This is also interval notations going from negative infinity to positive infinity. Notice I use the curved brackets because there is no exact ending place here. Infinity goes on forever, whereas this is an exact ending place. Now if you look at the cosine graph, you see that the cosine has the same domain and range in y. So domain and range, same as the sine. We can put any angle in, and it goes up to a high of 1 and down to a low of -1. Now the other thing I want to define, it says we have down here a periodic function. A periodic function is any function that repeats itself. The period is the number of units needed for one complete cycle of the graph before it starts to repeat itself. So if we go up here, we see that sine repeats itself. Here is one complete curve, and then it repeats itself. Here is one complete curve of cosine, then it repeats itself. So how many units does it go before it starts to repeat itself? Well, in this case, it's 360 degrees. So the period is equal to 360 degrees. Same thing for cosine. Now we'll look at tangent in a separate video because this is getting long enough as it is. Toodaloo.